My esteemed viewers, in this tutorial we discuss about some of the intricate features of the link layer, namely the MAC protocols, that is multiple access control protocols. Broadly speaking, a link layer does two broad functions. Of course, the gamut of functions that is being rendered by the link layer can be broadly thought of as two types. One is logical link control. Logical link control includes framing, error checking, error correction, providing general services and services to the flow of frames, providing full duplex or half duplex mode of communication. This is all about looking at the well-being of flow of frames and between node to node. There are no issues as far as the first functionality is concerned. It is the second functionality which is very much crucial, that is multiple access control. And in the first tutorial related to link layer, we have introduced that there are two types of network links. Of course, the link layer would control the local area network. Other than that, it will also control a chain of routers starting from the origin to destination, starting from the sender to receiver. And there are two kinds of links that may exist in the network, or in the LAN, or in the network of routers. It may be point-to-point link, and it may be a broadcast link. As far as a point-to-point link is concerned, it consists of a single sender and single node, single receiver, single sender and single receiver, single sender at one end and one end of the link, and single receiver at the other end of the link. But many link layer protocols, this is another example, and here is also another example where every end system is connected independently by some other end system. But many link layer protocols have been designed for a point-to-point links, and the point-to-point link protocol is one such protocol that we will cover maybe in the last tutorial. Okay, the second type of link is called as a broadcast link. It can have multiple sending and receiving nodes at all connected to the same single shared broadcast channel. Here you can see, here is a mainframe server, and it is connected to different end systems through a common link, and this is actually broadcast link. And here this is the access point, and this is the router, and this is connected to this one and this one and this one wirelessly. Therefore, there exist many channels as far as this access point is concerned. And once again, here is another example. In a ring topology, there exists only one link covering the every other nodes or every other end systems. Therefore, this will become a broadcast link. And in this case, here again it's a ring topology. Here again you can see the movement of the packets back and forth, and here is one more wherein this will happen somewhere inside the router chain, or inside the network, inside the link layer network, and there are several contending nodes which want to push their frames into a broadcast link. And when they do so, some of them will just go through that, and some of them will be involved in collision. So collision is a very big problem. The terminology associated with this collision is multiple access problem. So broadcast channels, I repeat once again, broadcast channels are often used in LANs networks that are geographically connected, centered in a single building also. Thus, we will also look at how multiple access channels are used in LANs at the maybe at the end of this particular section. We are familiar with notion of broadcasting. Television has been used since its invention, but traditional television is one-way broadcast. that is one fixed node transmitting to many receiving nodes, while nodes on a computer network broadcast channel can both send and receive. Perhaps a more apt human analogy for a broadcast channel is a cocktail party where many people gather in a large room, let us say, to talk and listen. A second good analogy is something many viewers will be familiar with. That is a classroom scenario where teachers and students similarly share the same single broadcast medium. A central problem in both scenarios, both in the cocktail party as well as in a classroom scenario, and therefore in a typical LAN scenario, is that determining who gets to talk and when. Okay, therefore some of the protocols which are meant for resolving this collision issue is based on human conversation, and as humans we have evolved an elaborate set of protocols for sharing the broadcast channel. I would read it out. Give everyone a chance to speak. Don't speak until you are spoken to. Don't monopolize the conversation. Raise your hand if you have a question. Don't interrupt when somebody is speaking. Don't fall asleep when someone is talking. Because all nodes are capable of transmitting the frames, more than two nodes can transmit frames at the same time, as it was seen earlier. Okay, more than okay, multiple contenders can definitely send the send their frames, and they are subjected to collision. So collision is a real issue. Some of them may escape also, some of them may be successfully posted across the broadcast channel. When the transmitted frames collide at all of the receivers, typically when there is a collision, none of the receiving nodes can make any sense of any of the frames that were transmitted, which is obvious. In a sense, the signals of the colliding frames become inextricably tangled together. They will crumble together. Thus, all the frames involved in the collision are lost, and the broadcast channel is wasted during the collision interval. Clearly, if many nodes want to transmit frames frequently, many transmissions will result in collisions, and much of the bandwidth of the broadcast channel will be wasted. Therefore, there are protocols which are meant to resolve this particular issue, that is multiple access control protocols, or media access control protocols. They are traditionally called. They are of three types. Okay, the avoidance of collision will be done by the protocols. They are channel partitioning protocols, random access protocols, and taking turns protocols. I repeat, the multiple access control protocols or media access control protocols, here media being a broadcast media. There are three protocols, okay, which have been designed by network engineers. It is channel partitioning protocol, random access protocol, and taking turns protocol. Channel partitioning protocols, it has been told already earlier in the first few tutorials, particularly in the first chapter itself, that is the introduction to computer networks. I think second tutorial, this has been elaborated. That is, channel can be partitioned by three ways. One is frequency division multiplexing, time division multiplexing, and statistical time division multiplexing. In frequency, anyway, for a recall and for the sake of completeness, we will just mention them again. Frequency division multiplexing involves the bandwidth of the channel being partitioned. That means the broadcast channel is assumed to be made out of innumerable number of layers, each layer capable of dealing with a particular range of frequency. Therefore, there are layers of frequency. Okay, the typical example is a TV connection wherein a cable will be serving multiple stations. A link is assumed to be made out of layers of frequency. This is the strategy as far as frequency division multiplexing is concerned. Since a channel is made out of resolved into different frequency level, every contesting node every contender will feel that channel is theirs, the broadcast channel is theirs. And TDM, as far as time division multiplexing is concerned, the transaction time will be divided into frames, as many frames as there are contenders, and each and every frame is divided into slots, okay, as many slots as there are containers, or they are also called as quanta. Okay, and this quanta or slot happens to be very minute amount of time. Of course, it is no time at all, but anyway, each and every contestant or each and every contender will be given this particular bit of time, and they always feel that their broadcast channel is theirs. And in a statistical time division multiplexing, the time allocation to each node is based on usage pattern. If a particular node is using heavily, then that will be given on demand, so that time will be allotted on demand. Okay. Then comes random access protocols. Of course, random access protocols will be dealt in detail. It is the second broad class of multiple access protocols. They are coming to be called as random access protocols. In this case, a transmitting node always transmits at the full rate of the channel, namely or bits per second. When there is a collision, each node involved in the collision repeatedly transmits its frame. Okay, they keep on transmitting the frame until the frame gets through without a collision. That's all. Try and try again. That is the policy over here. But when a node experiences a collision, it comes with a little flavor, of course, but when a node experiences a collision, it does not necessarily transmit the frame right away. Instead, it waits for a random amount of time, random delay before transmitting the frame. So the name random access protocol comes from this fact, because when it happens to be the second transmission, they will never suddenly transmit their frames. Instead, they wait for random amount of time. Each node involved in a collision chooses independent random delays. Because the random delays are independently chosen, it is possible that one of the nodes will pick a delay that is sufficiently less than the delays of the other colliding nodes, and will therefore be able to sneak or will be able to find a place through the broadcast channel, and they will be finding the chance to sneak through the broadcast channel. Okay, I repeat, each node involved in a collision, as far as random access protocols are concerned, they are not independently they are independently chosen. They are independently given random amount of time for which they have to wait. That means they cannot surge. As soon as they notice a node, contesting node cannot surge its frame as soon as the collision is noticed. It has to wait for random amount of time, and therefore the name of the protocol. There are three protocols considered under this particular strategy, that is slotted ALOHA, pure ALOHA, CSMA, and that is carrier sense multiple access, and carrier sense multiple access and collision detection algorithms or protocols. We will discuss about slotted ALOHA. ALOHA here, there is no LOHA, there is no metal over here. It is a I think it is adapted for a network, in the I think Hawaiian networks. Somewhere it was adapted, therefore the name. Okay, and as far as slotted ALOHA is concerned, all frames, there are some assumptions. Okay, let us begin our study of random access protocols with one of the most simple random access protocol. ALOHA, slotted ALOHA is called as most simple random access protocol. The slotted ALOHA protocol is the slotted ALOHA protocol. Of course, it comes with assumptions. Of course, all frames consist of exactly L bits, all the frames. Time is divided into slots of size L by R seconds. That is L, where L is the length of the frame and R is the data rate of the channel. That is, a slot equals the time to transmit one frame. I think our respected viewers can recall that L by R happens to be the transmission delay. So each and every packet, that is every frame that is to be sent by different contestants or different contenders will be given a slot. That means, let us say, if the first node transmits its frame, the second node, if the chance is its chance, then it has to wait at least for L by R seconds. Otherwise, till then it cannot push its frame because it will involve in collision. Therefore, time is divided into slots of size L by R seconds. Therefore, this is called as a slot. Nodes will start to transmit the frames only at the beginning of the slots. It cannot send somewhere in between because there is already a frame in the move. There is already a frame in the transit. The nodes are synchronized so that each node knows when exactly the slots will begin. This is something like blowing the whistle in a running race, but here only one participant will take on to run, the others have to keep quiet because they know that a fellow has already started running. It's something like this. Okay, the protocol is the whistle blower. Okay, if two or more frames collide in a slot, then all the nodes detect the collision event before the slot ends. If at all some of the nodes push their frames, okay, if two or more frames are collide in a slot, then all the nodes detect the collision even before the slot ends. And here you can see in the figure, in this particular figure, nodes 1, 2 and 3 collide in the very first slot because they are trying to rush through the channel in the very first slot itself, and they happen to be coming exactly at the same instance of time. Therefore, they involve in the collision. Node 2 finally succeeds over here. Node 2 finally succeeds possibly in 1, 2, 3, fourth slot, and node 1 here will succeed in the 8th slot. Of course, 8th slot, you can just count down over here, and node 3 in the 9th slot. Okay, it can push its frame only in the 9th slot, and each and every slot will come with an equal amount of time, that is called as transmission delay, because the length of each and every frame is assumed to be constant. If P is the probability, that is a number between 0 and 1, of course we know the operation of slotted ALOHA in each node is very simple. When the node has a fresh frame to send, it waits until the beginning of the next slot and transmits the entire frame in the slot. If there is no collision, the node has successfully transmitted its frame and thus need not consider retransmitting the frame. If there is a collision, the node detects the collision before the end of the slot and it will retract. This is called as backup. Okay, the node retransmits its frame in each subsequent slot with probability P until the frame is transmitted without a collision. This is something like trying again and again, of course with a probability. Therefore, randomness is associated with this probabilistic time. Okay, we will take up the other protocols in the next tutorial. And before that, I want to convey to our viewers that there is some error that is crept in CRC method that I will be correcting over here. Okay, mistakenly by overlook, I told the CRC involved. I took a simple example, of course, to begin with. Let 9 be the data. I told 9 be the data and 2 be the divisor. So 9 is the dividend and 2 is the divisor. The methodology in simple is explained something like this. 9 is divided by 2. The remainder is 1. 2 4s are 8. And the 9 is the data, actual data. So 9 is minused with 1. I told it is added, but it is not added. It is minused with 1. So 9 minus 1 becomes 8. And it is this 8 that will be sent. Or data will be sent, the remainder will be sent, and the divisor will also be sent. And with respect to CRC, this is data, a bit stream, and this is the standard accepted divisors which comes through industry standards, and any one of them should be accepted depending upon the length of the data. More is the length of the data, more will be the length of the divisor, so that error can be detected with all the foolproofness. Anyway, so here in the example, this is what which remains. Okay, so 3x cube 2x square plus 10x plus 20 is the data that is to be sent, and 73 minus 73 happens to be the remainder, and minus 73 is to be negated, is to be subtracted. Therefore it becomes minus of minus plus. So 3x cube 2x square 10x plus 93. So when 93 is over here, when we multiply 31 by 31 into 3, it becomes 93 again. So 93 will cancel at the receiving end, and there won't be any errors. If there is a remainder at the receiving end, once again the receiver will be able to understand that errors must have crept somewhere. Okay, I told CRC method is a robust method and all other things remains the same. I regret this particular error. So we come to the end of this tutorial number 3, which is solely meant for explaining the routing, the multiple access control protocols, and we have explained only sorted ALOHA as far as random access protocol is concerned. And we knew actually channel partitioning protocols in a different way in the introduction chapter, in the very first chapter, in the very first tutorial, in the second tutorial, of course. Okay, and my respected viewers can get back to that, and they can understand. Okay, again it can be a rehearsal, and problems were also solved in that particular category of this thing. Okay, the channel partitioning. Of course, when we discussed the circuits switched networks, we brought this into discussion. Okay, with this we end up this, and if you like this video, kindly